Okay, I thought I'd do 9.7c. Since if you can do C, you can probably then do A, B, and the other ones. So this is an example. You can do C to help you do the other ones. So this is what it looks like. We have a function negative x squared plus 3. And they want us to do about everything in this section, which is good practice. So it's good to do, which is graphing it, finding the domain, the range, which means the domain and range of the inverse function, because they're just switched. So actually do it once and you're pretty much done. So let's look at the domain and range. They tell us x greater than or equal to 0, just because they can. So obviously that's our domain. They didn't have to say that, but they did. We could have had any x we wanted. But they're saying x greater than or equal to 0, so okay, that's the domain. Then the range, we can just see, okay, when x is greater than or equal to 0, what possibly can it be? Well, when x is 0, it's 3. And as x gets bigger, x squared is always positive, but it's negative, so it's going to go from 3 and then lower and lower and lower and lower all the way to negative infinity. So the biggest it's going to be is 3, and then it's going to get more and more negative as x gets bigger. So the range then would be, let's see, negative infinity to 3. And really, I shouldn't put a bracket like that for a negative infinity because you can't ever include infinity. So really it should be a regular bracket like that, not a squarish bracket for parentheses. So because you can't ever include negative infinity. Okay, so that's the domain and range. So the inverse function would be switched for f negative 1 of x, the one that cancels this one out, and we just get x back, it would be switched. So the range is here and the domain is there. Okay, then to find it, we just call this y. Let's call it, just because it's easier to do math with y than f of x. So we say y equals negative x squared plus 3, and then you solve for x as a function of y. So we put the 3 on the other side, y minus 3 equals negative x squared. Let's negativize everything, so make this side negative to get rid of the negative there. So we have negative y plus 3 equals x squared. Now take the square root of both sides. And we have, I'm going to put it 3 minus y because that just looks nicer. So x is equal to plus or minus the square root of 3 minus y. Okay, but x is greater than or equal to 0, so we can't have it less than 0, so it can't be negative, so we have to choose the positive there. So finally our function then we can safely say is x is equal to the square root of 3 minus y. Okay, so now notice it works really nicely with the range. We plug in negative infinity for y, minus negative infinity is positive, so as long as y is negative, I mean the domain, right, the old range here is the domain of the inverse function, so plug in negative infinity, we get 3 minus negative infinity, which is a positive number, and the biggest y can be is 3, we plug in 3 we get 0, and that's okay too, so we're not violating any rule, so it worked out really nice. Okay, now they suggested that we now try and see if we're right. Okay, so I'm going to do that over here. So what is f negative 1 of f of x? We should get x when we do that. So we take our inverse function, which is the one we just found, which is this thing here, of x, and we plug in f of x everywhere we see a y. So it's kind of weird that x's and y's get mixed up. A lot of times actually you would take the inverse function and call that y. So here we had it as x. So let's now, because normally we call a function y, is a function of x. So it would be square root of 3 minus x is our new function. Either way works just as long as you know what you're talking about. So in here we'd take f of x and plug it in for y in the inverse function, or in this case since I just did it for x. So that would be, let's see, we take our function, our negative, and we go 3 minus, and everywhere there's an x, we plug in f of x, which is why we studied this stuff last chapter. F of x is this thing up here. So we plug in 3 minus negative x squared plus 3. And let's see, that works out to 3 plus x squared minus 3. The 3's go away, so that's just the square root of x squared then, because the 3's cancel, which is x. And sure enough, f negative 1 of f of x gives us x, which is the whole point. The negative inverse function cancels out the function. Let's try it the other way. F of f negative 1 of x. Okay, so we take our function f, which is negative x squared plus 3. Everywhere there's an x, we plug in this. We plug in the inverse function. So it starts off as negative x squared. We plug in the inverse function, which is square root of 3 minus x squared plus 3. So again, negative x squared plus 3. Everywhere there's an x, we plug in the inverse function. Well, that is negative, this squared, of course, is just 3 minus x plus 3. Negative 3 plus 3 cancels, negative x, we just get x back. So it works. A function of an inverse function or an inverse of a regular function always just get you x back. They cancel each other out. Okay, the last thing they want you to do, so a lot of steps for each problem, but that's okay, it's a good problem, is to graph the stuff. Okay, so usually the inverse function is easy to graph, negative x squared plus 3. And you don't have to do a beautiful graph, just kind of, okay, so negative x squared plus 3. So let's see, I know negative x squared is an upside down thing that looks like this. Plus 3 just raises it 3 higher, so it looks like this. There's our negative x squared, opens downwards, and oh, we raise it 3 higher, so that would be right there, that would be at 3. Now they said x greater than or equal to 0. So actually, all this stuff doesn't count. Okay, so you scratch that out, or if you have a pencil, which is a good thing, you can erase it. Okay, so all we're talking about is this part right here. Okay, this is the y-axis, this is the x-axis. To do the inverse function, this is f of x. To do f negative 1 of x, it's like when we solved up here, we switched the y's and the x's. Here we have x as a function of y is a function of x, now we have x as a function of y. So all we do is we switch the x and y axes. To do that, let's see, we put the y over here, so first step is we rotate it 90 degrees that way, so 90 degrees clockwise, so that would put the y here. Problem is, that puts the x, makes it negative. We want to then flip it back upside down. So the second step then is to flip the graph about the x-axis, which is now the y-axis, so we should just call it the horizontal axis. Then it's just like we switch the x's and y's. The y becomes here, the x is here, oops, we want it back up here, we want positive x up here, positive y here, so we have to flip it like that. So to graph the first one, then take it, rotate it 90 degrees, flip about the horizontal axis to do the second one. So again, a pencil helps, this is going to be a mess. See how well I can do. So we take this thing here, so you rotate it 90 degrees, okay, so that would mean it comes out of here, and now it looks like this. Okay, so the first step, we take that thing there, now it's here, so it looks like this, and then we flip it about the horizontal axis, so now it looks like this. Well, that's 3 right there. So this cancels out then, and so our final f negative 1 looks like that. So again, rotate it, starting here, it starts here, it goes like that, and then flip it about the x-axis. And that's all you do. Usually the regular function is pretty easy to graph, and then for the inverse function, you just flip it like that. And that should work. And then all the domains and ranges should work out just right. We can see here, the domain here of x is 3 to negative infinity, and sure enough, the range of our original function, which is the domain of the inverse, is from negative infinity to 3. So it's really cool how all that works out so nicely. Alright, hope that helped. Again, let me know if you have trouble with the other ones, and I'll probably do one of the word ones later and share that. So, okay, bye.